Hey, everybody, welcome to our discussion this morning. We have Dr. Hugh Ross back with us. As you guys may know, that Dr. Hugh Ross is the founder and president of Reasons to Believe, an organization dedicated to integrating scientific fact and biblical faith. His books include Why the Universe is That Way It Is, Why the Universe is the Way It Is, Hidden Treasures in the Book of Job, and Navigating Genesis, and of course, Improbable Planet, which is the book we're going to be discussing this morning. And hang on one sec, I got to turn off my live feed or else I'm going to get feedback. One sec. Okay, there we go. So anyways, Hugh, welcome back to the Great Debate Community. I know you remember us.
Sure.
Awesome. I have to tell you, before we even start, I was actually quite surprised. It reads much more like a scientific text filled with just science information than it does as a book on apologetics. So I wanted to throw that out there real quick, that it was a lot different than I had expected. But you know why did you write this book, though? I mean, what was your goal in actually writing this book, as far as your argument that our planet is special and unique?
Well, the book actually goes back 5 years when I was teaching a study of all the creation texts in the Bible. And what I noted is every major text links the doctrine of creation with the doctrine of redemption. And then I found texts in the Bible that says that God begins his works of redemption before he creates anything. And that seemed to suggest that all of God's works of creation are for the purpose of making possible billions of human beings coming into an eternal relationship with him. So I decided to put that to a scientific test. And I spent 3 years going through the scientific literature in all different disciplines to see, is it really true that every event in the universe, Earth and Earth's life, and every component of the universe, Earth and Earth's life, fulfills some role in making possible billions of human beings actually living on planet Earth at one time in such a way that they could receive the message of redemption through the Creator. And so what you see in the book is basically a summary of some of the highlights of that survey of the scientific literature. And that may explain why it reads like a science text and why it has so many citations to the scientific literature. And what I love about our editors, they actually provided links to all the research papers. That's something you can do now in book publishing, and actually give readers direct links to the research papers so they can dig into it in greater detail themselves.
Can you just briefly, though, because for the people that have not read this book, can you kind of just explain what you mean by Improbable Planet as a title? I mean, you go into great detail about why we are improbable, or why you believe that we're improbable, and each conditions that are required to have sentient life as we know it. I mean, you start off going into, you know, how we had to have certain events have to take place, oxygenation events, habitable zones,
Right.
and in great detail, a matter of fact, what is required to have the type of life that we have now.
Yeah, that's right. And, you know, the title was not my choice. That was the choice of the publisher, because lots of books have been written on the rare earth hypothesis. What I was trying to do in this book is show, okay, we do have literally dozens of books saying how unlikely it is that you can have a planet in the universe that can even sustain any kind of life. But how the fine-tuning goes way up if you want something beyond microbial life. And it goes up again if you want flowering plants and animals. And it's particularly spectacular if you want human beings. What I was doing in this book is taking the next step and saying, if you want billions of humans to be able to live somewhere on a body in the universe within a relatively short period of time, say 10,000 years, we see an enormous jump in the improbability of any body in the universe being able to do that, and particularly to have those billions of human beings with the technology that they could actually engage in philosophy and theology and consider questions like, why am I here? Is there life beyond this life here on Earth? What is the purpose for God creating the universe? What's his purpose for creating me? And can we actually be delivered from the problem of evil we see all around us? And so realizing that indeed God created the universe, Earth and Earth's life, not just to make a home for us, but to actually fulfill the purpose and destiny for God creating the universe and human beings. And that explains why I need to go through such an exhaustive scientific study that you see summarized in the book. I mean, if I wanted to, I think I could have written 12 books just based on all the scientific research that we did over that 3-year period.
Well, yeah, I think each chapter there probably could have been its own book as far as
Right,
detail.
right.
But I'm glad you brought up the fine-tuning argument, because Paula Gia had asked that just prior to you coming in. Is this a type of fine-tuning argument? And I'm not sure how to answer that, because the way I understand a fine-tuning argument really goes to the constants of the universe. If they weren't the way they were, we wouldn't exist, which I think is a poor argument. However, if yours is more of a different type of fine-tuning argument, that these are the conditions for sentient life and technologically advanced life. Is that a type of fine-tuning? And then Paul could actually ask it in his way.
Yeah, you can go to our website, reasons.org/fine-tuning. That will pop up a 300-page compendium where we actually look at the fine-tuning evidence, not just in the context of the laws of physics, but what kind of gross features of the universe do you need? Then we begin to look at what kind of galaxy cluster you need, what kind of galaxy within that galaxy cluster, what kind of planetary system, what kind of star, what kind of planets, what conditions you need in the Earth. Then we subdivide that argument. What do you need to make bacteria exist on a planet for, say, a 90-day window? And what do you need if you want bacteria existing for 3 billion years? And what do you need if you want to have plants and animals? And finally, what do you need if you want to have human beings? And we're hoping to be able to update that compendium. What do you need to have billions of human beings living on a body within a 10,000-year window or shorter? And then what do you need for them to actually be able to engage in philosophical and theological discussions?
Yeah, well, you had actually mentioned it here about like spiral galaxies. Life couldn't exist without spiral galaxies, and that's not too contentious, right? I mean, I've actually looked into that, and that's pretty much the standard for astrophysics. That's mostly what people are saying. Would you agree?
I would agree, but we take it one step farther and say you not only need a spiral galaxy to have life. If you want to have advanced life, plants and animals and human beings, then you need a very special kind of spiral galaxy, one with highly symmetrical arms where that symmetry is maintained for billions of years, where the galaxy is a certain size, relatively large size, but with a very small, relatively small central black hole, supermassive black hole. And then you need to have a spiral galaxy with not very many feathers or spurs. And you want it to have dwarf galaxies that are quite large that actually cause a gravitational drift in of that sufficient gas at a sufficient rate that it can sustain the spiral structure of that period of time. Bottom line, nearly 200 different features of our Milky Way galaxy must be fine-tuned if you want to have advanced human civilization on a planet within that galaxy.
Let me bring Paul on real quick. Actually, let me introduce everybody on the panel. You recognize some of the people before you. Obviously, you know General Han Solo. You remember him, I hope.
Yes.
And Wayne Fillmore.
Yes.
Okay, and then you may or may not know, obviously, Paula Gia, Hunter Bailey, and Mel the scientist. They're kind of newer to the Great Debate. Well, Hunter's been around.
I've met them before. Thank you.
I think you might have. Okay, so Paul, do you want to more inquire about the fine-tuning argument? Because you had a good question prior.
Yeah. So, well, two quick questions. One is because Steve and I are constantly debating about things. So, just to clarify, so Hugh, you would say that overall your book is generally a fine-tuning argument. It would be within the family of the fine-tuning arguments.
Well, fine-tuning is just one part of the book. I mean, I also get into what kind of life history do you need to have human beings? What kind of ice and no ice history do you need of the Earth in order to get lots of human beings here?
Gotcha.
So fine-tuning is probably maybe 1/4 of the book. The other 3/4 deals with other subjects.
Okay, then Steve wins. That's all right. And then I guess my other question in general, I'm assuming you've heard of the Douglas Adams puddle analogy, and just in case anyone in the audience hasn't heard it, you know, Douglas Adams supposed a sentient puddle, a puddle that came to life, and he woke up and he was just astonished that someone had made a hole in the ground that exactly fit, you know, the shape that the puddle was. And of course, the opposite is true. The puddle was made to shape the hole in which it lived. So for someone like me, for whom that is a compelling idea, and for whom it just obviously we are going to be made to fit the universe we are in, as opposed to the other way around. What did you find? What did you learn that might convince someone like me that it's the other way around, that the universe was made for us?
Yeah, scientists don't delve in that anymore, mainly because about 25 years ago, the British philosopher Richard Swinburne wrote an article, and then it got into pieces of his book on why that's not a logical approach. He basically used an analogy, and he said, think of someone who's been convicted of a firing squad execution, and you got 12 sharpshooters with high-powered rifles and telescopic sights, and they're told to put a bullet through the man's heart. And they all fire their guns, and he survives. And he says, well, of course I survived. They all missed. But Richard Swinburne's point is they failed to recognize it didn't make logical sense for them to miss if their purpose was to kill him. Somebody must have had a reason for that person who's to be executed to survive. Either somebody put blanks in their guns, or all 12 purposely aimed their guns away from his body. And likewise, they say the fine-tuning argument isn't as simple as just saying, well, of course the universe is this the way it is, otherwise we wouldn't be here to observe it unless it was that way. You need to dig deeper philosophically and say, okay, what is the purpose behind this? And so that's been a settled argument literally for about 25 years. And so now we see other attempts to try to avoid the theological implications of fine-tuning. I write about that in Improbable Planet, and how the anthropic principle, this idea that the universe and our galaxy and solar system were designed for human beings, has basically been reduced to what's called a prebiotic principle. What kind of characteristics do we need to have the possibility that the building blocks for life would exist? And there you get a much lower degree of fine-tuning than you would if you're talking, what do you need to get human beings? And so I think it's a fellow by the name of Marcello, a physicist, has said the anthropic principle has evolved into a prebiotic principle in order to avoid the theistic implications. And this is why we have that fine-tuning compendium, making the point that fine-tuning rises dramatically as you begin to look at more and more advanced forms of life.
Now, do you subscribe to the strong anthropic or just the weak?
The weak anthropic principle, as I understand, the strong anthropic principle is making the point that the universe must have the characteristics that allows life to be possible. And as an astronomer, I can think of many ways you could have the universe where no life would exist at all. In fact, way more ways than having the universe that would sustain life. So yeah, I don't buy the strong anthropic principle.
Right, I agree with that as well. The weak anthropic is fine. The strong, I think, would be a too high a level of to try to actually hold that particular position.
Well, it really misunderstands the laws of physics and the gross features of the universe.
Mel, before you came in too, you had a couple questions that you wanted to ask, I think. Did you not?
Yes. I'm fairly new to Dr. Ross's work, so I have a couple questions. I'm curious about your thoughts on the Drake equation. I imagine you're pretty familiar with that as far as the possibilities of life outside of our own. How do you feel about the possibilities of there being technologically, not necessarily advanced species, but perhaps at one time there were, maybe even before us?
Yes, well, I had the privilege of taking short courses from both Frank Drake and Carl Sagan, who really promoted that idea, and there's been lots of papers published on it since. What I do cite in Improbable Planet is a major oversight. What's happening, what's fueling the Drake equation is when we look on planet Earth, we see that life arose here on planet Earth as early as the laws of physics would permit. It's literally impossible, given the physics of the universe, to have an origin of life earlier than what took place here on planet Earth anywhere else in the universe. And also we note that the origin of life was extremely rapid. I mean, immeasurably rapid on the face of the Earth, which has led a lot of astronomers to conclude, therefore, the origin of life must be a very easy step, since it happened as early as possible and it happened immediately without any measurable time delay. But what they're overlooking is, unless the origin of life happens as early as the laws of physics would permit, and unless it happens extremely rapidly, you will not have enough time for the universe to change in such a way to get human beings before it's impossible to have any life on a planet. And so when we recognize that you can't bring human beings on the face of the Earth in large numbers anyway, in anything less than 3.8 billion years, now we begin to realize maybe the origin of life is not such an easy step after all. And what I document in Improbable Planet is what we've been able to see by attending origin of life research conferences and reading the research papers. In fact, we just attended an origin of life research conference this past July at the University of California in San Diego. And the conclusion of that conference was, not only do we not have any idea how chemistry brought about the first life, we don't even know how the first building blocks came together. Matter of fact, they said, we don't know how you get the building blocks necessary to get the building blocks to make life possible. And so,
well, I have another question. My background is primarily in biochemistry, as well as analytical chemistry, biology, human biology, genetics, that sort of thing. So about the Miller-Urey experiment, did they not show that there was very good conditions at that point in time for amino acid formation, not formation?
Yeah. Well, that was a big subject of the Origin of Life conference that we attended back in July, and also in previous conferences that we've attended. Bottom line is the Urey-Miller experiment is irrelevant to the origin of life on planet Earth because it presumed conditions that we know are not true for the early Earth. For example, they presumed that there was no oxygen present in the ocean or the atmosphere. Now, we do know there wasn't a lot of oxygen, but the problem with the Urey-Miller experiment is even the tiniest amount of oxygen shuts down the prebiotic chemistry. And so just the fact that you've got a lot of uranium and thorium in the Earth. Matter of fact, I argue in Improbable Planet, we probably are living on the most uranium, thorium-rich body in the entire universe. And just the radioactive decay of uranium, thorium will produce sufficient oxygen to stop the prebiotic chemistry. Never mind the fact that you've got ultraviolet radiation pouring in from the sun, because that's something else that they did. Is they made sure no ultraviolet radiation is coming in, because that's deadly to life. And you got what's called the ultraviolet oxygen paradox. If you got oxygen, that stops the prebiotic chemistry. But if you don't have oxygen, then the ultraviolet radiation comes through at such intense levels that also stops the prebiotic chemistry.
I'm a bit curious then when we apply that to the water bears, because they're able to survive cosmic radiation.
Pardon me?
The water bears? Are you familiar with those?
Oh, yeah, the water bears.
Tardigrades, yeah. I'm used to calling them water bears. But tardigrades, can't they survive cosmic radiation in the vacuum of space?
There are bacteria that can survive very hard radiation, but there's a paper you can see in astrobiology. Its title was "Extremophiles Are Irrelevant to the Origin of Life," and basically makes the point you can have extremophiles if you've got mesophiles coexisting with them. But to try to get the origin of life under extremophilic conditions is orders of magnitude more challenging than to do it for the mesophiles. And if you actually look at these life forms that are very radiation tolerant, most of their energy that they're exploiting goes for repair mechanisms. And so these are species of life that have very low metabolic rates because all their energy is going to repairing damage that's taking place all the time. And also they're extremely slow evolvers. again, because so much of the energy is going to the repair mechanisms. But yeah, if you just go astrobiology journal, extremophiles are relevant to the origin of life, that article will pop right up, and you'll see it cited in my book, Improbable Planet.
Real quick though, I mean, they did repeat the Urey-Miller experiment quite a few times with different types of combinations of gases. I mean, the whole point of that was not to just to be able to show that complex carbons can form under given conditions. The first one, I believe, had 6 amino acids forming, and then subsequently they had, I think, as much as 19 or 20 or something form with other experiments. Just to show that these complex molecules can form under all kinds of different conditions. Is that correct?
Well, the Urey-Miller experiment, I mean, the first time they ran it, they got nothing. What's interesting is the first runs, they ran it 200 times, and they got glycine on one of those 200, and at a very low abundance level. And of course, glycine is the simplest of the amino acids. It's only got 10 atoms in it. And they were able, in future experiments, to get a few more of the simpler amino acids. The complex ones, you can manufacture them in labs, but it takes very sophisticated laboratory controlled conditions to get the more complex amino acids. And they've not been able to make ribose under those conditions. And the bottom line is, if this is really how the origin of life happened, you need to be able to find outside of a biochemistry lab where you get tryptophan, where you get ribose, where you get the more complex amino acids, where you get the nucleobases, and where you get the sugars that you need. And this is something we see missing in the naturalistic realm. I mean, as an astronomer, I can tell you the best place to look for those things is interstellar molecular clouds. It's the richest naturalistic source of carbonaceous molecules. They found over 135 of these molecules, all the way up to 3 carbon sugars they've been able to find. But we've yet to find a single amino acids. We've yet to find a single nucleobase or any of the 5 carbon sugars. And we've yet to see any solution to the homochirality problem. I mean, you can have all these molecules, but if they're not homochiral, you're not going to have an origin of life. And everywhere we look, we see racemic mixtures. So yes, we can do it in the lab. And my colleague, our staff biochemist, Fazal Rana, wrote a book, Creating Life in the Lab. We can do amazing things in the lab, but they're irrelevant to what takes place in the natural realm. In fact, my colleague, Fazal Rana, wrote that book making a point. It's going to take someone with a lot more financial backing, a lot more knowledge and intelligence, and lab equipment to make the origin of life on planet Earth. So he's basically arguing someone way more intelligent, knowledgeable than us must be responsible for the origin of life, just because of how difficult it is for us to do it in expensive, well-equipped biochemistry labs.
Now, I have read before, though, that ribose has been produced under similar conditions that we would expect to find in space, even if we haven't found ribose in space. Is that true?
They've done experiments in the lab where they can make ribose. Yes, you can make ribose in the lab. You can make very complex molecules. One thing you notice, however, you read the research papers, they're made with great difficulty. They're not easy to make, and they decay very rapidly. And this is the problem. In fact, I believe that there is ribose in these interstellar molecular clouds. I'm convinced of that because we know the chemistry that we use in the lab to make ribose operates in these interstellar molecular clouds. So it's simply a matter of time before we find that ribose. But we also know it's unstable. And so I've been on record predicting we will find ribose in interstellar molecular clouds, but it's going to be a parts per billion or less. And of course, with that low of an abundance level, that's of no help to any naturalistic origin of life model. But so far, we've not been able to find the ribose, even though we know it's got to be there. I think even more challenging are the basic amino acids like tryptophan. That's even harder to make under naturalistic conditions. But once again, based on how we've been able to make tryptophan in the lab, I'm convinced we eventually will find it. in these interstellar molecular clouds, but it's probably going to be a parts per trillion. And right now, we don't have the technology to detect molecules at that an extremely low abundance level.
And the other thing I want to ask real quick before I turn back over to Mel, because I can't find the page number, and I didn't bookmark it. I'm sorry, but you had mentioned earlier something about the concentration and ratios of uranium to thorium, and then you just had mentioned that it was detrimental to life. Yet at the same time, I had noted that what part of the argument is that we couldn't even exist without the radiometric decay from these two very abundant elements, because they're just such high quantities that leads into the thermal heating of the Earth. I mean, obviously, plate tectonics probably wouldn't exist without the radiometric decay. So is it
Right.
kind of like a trade-off?
Yes, I mean, uranium and thorium do affect our lifespan. I mean, I happen to be living in California, which has relatively uranium-rich soil. So I know I'm not going to live quite as long. I mean, that's going to limit my lifespan by about months compared to people living in the prairies. But hey, they got other problems to deal with that I don't have to deal with. So yeah, it is a limiting factor for life. On the other hand, there'd be no plants and animals on the face of the Earth if it wasn't for Earth being super endowed with uranium and thorium, because it's the heat release from uranium and thorium that drives the plate tectonics. And without the plate tectonics, you're not going to get a planet where you got oceans and continents coexisting. And if you don't have oceans and continents coexisting, you're not going to be able to recycle the nutrients that long-lasting life will need. That's something I kind of lay out on Improbable Planet. It's one thing to have a planet with life on it. It's quite another matter to have life existing for billions of years, which is what you need in order to have advanced human civilization. I mean, humans are the beneficiaries of quadrillions of tons of biodeposits that have been laid down by billions of years of life that pre-existed us.
I do believe that actually the soil for Utah is one of the hotter spots because of the radium test, the testing that they did at White Sands and other places. Unfortunately, I'm in the same boat as you because I used to work with nuclear reactors and I was exposed to radiation a lot. But well, I mean, minor compared to what most people would think is a lot. But I mean, obviously more than the average person. But I don't that hopefully it didn't affect my longevity too much. But I am familiar with what you're saying as far as the background radiation does affect how long you're expected to live, correct? I mean, these are cumulative radiological effects, correct?
That's right. I mean, the fact is every human being is exposed to igneous rocks, and there's lots of uranium and thorium in igneous rocks. So that's a fundamental limitation on how long any human being can live.
Mel, do you want to do a follow-up real quick on your Drake equation? Because I think that's a great question for the Drake equation. The only thing I have to add on is that I think the Drake equation kind of puts like all the things in this one book from Improbable Planet into like one or two terms in the Drake equation. I think Hugh breaks it down a lot more in detail of what would be required to have a habitable zone, correct?
Yes, and I do make the point that the Drake equation is basically taking highly improbable factors and multiplying them together. But if any one of those factors has a probability of 0, then the answer from the Drake equation must be 0. And there's several factors in the Drake equation that from a naturalistic perspective, I think you can argue must be indistinguishable from 0. And that would mean that we're the only intelligent species within the universe. And I did cite a couple of papers, and they've just been very recently published to the effect, and you'll see an update article on our reasons.org website that I wrote from even papers making the point that we must be the first because it's impossible to bring intelligent life existing anywhere in the universe any earlier than the appearance of us human beings. So astronomers are making the point, maybe you could have intelligent life after us, but not before us.
Is that the lower bound? Okay, let's assume that the universe, obviously, I think everybody here agrees about 13.8 billion years old. What would be the upper bound of the conditions that would be available to have any kind of life produced? I mean, obviously, a billion years after the formation of the universe, I don't think life would have been anywhere could have existed, correct?
Well, yeah, you need several generations of star formation and star death just to get the basic elements you need to make life possible. And so that requires billions of years of cosmic history, even to have bacteria on the face of a planet. And so you can get the simplest bacterial life forms when the universe is, about 9.5 billion years old. But if you want human beings, you need, and that's basically what I talk about on Improbable Planet, you need a very highly specified sequence of the development of life over the course of 3.8 billion years in order for us to appear. So yeah, you can get bacterial life in the universe a lot earlier than 13.8 billion years. But if you want human beings, it really does take the full measure of that time. And where I would disagree with my colleagues, they claim that in the future you could have advanced species of life. But what they're failing to consider, not only is there a lower bound to when you could have human life, there's also an upper bound. And that upper bound is not very far away from the lower bound. But that's kind of where the book ends, where I make the point that if you want billions of humans or the equivalent of humans living on a body in the universe, the time window in which that could happen is briefer than 100,000 years. In fact, it looks like it's briefer than 20,000 years.
So you're saying that the upper and lower bounds are pretty close together.
They're very close together.
Yeah. And you make a note, and I'll turn back over to Mel here in a second. You make a note, again, didn't bookmark it, but you make a note about the stellar luminosity being consistent over 100,000 years due to the proton-proton neutrinos and the photons ratios, correct?
Yes, and
I was interested in that part because I found very fascinating, because I read up on that a little bit. And can you explain a little bit why you can say that the luminosity of the sun has not changed in at least 100,000 years?
Well, you get bacteria showing up on the face of the Earth 3.825 billion years ago. That's now established a very high accuracy. But that's a time when the sun is pouring out way more ultraviolet radiation, X-ray radiation. Big flares are happening frequently. And bacteria can handle that, but nothing more advanced than a microbe can withstand that kind of solar radiation and variation in its luminosity. But as the sun gets older and older, we see that flux of ultraviolet and X-ray radiation subsides in proportion to its age. And likewise, the flaring activity subsides. And we're talking with respect to the flaring, it subsides by about a factor of 1,000,000 times. So today we're living in a narrow window of the time's history when the flaring activity is about 1,000,000 times lower than it was when Earth was first formed. And as we go into the future, the flaring activity will increase. I mean, there's a graph I show in the book where I show you the flaring activity and the ultraviolet X-ray radiation flux with respect to the age of the sun. And now we realize this is true of all stars. All stars approach minimum flaring activity and minimum X-ray and ultraviolet flux when they're exactly middle age. And that's where the sun is right now. The sun can burn hydrogen into helium for about 9 billion years, and we're halfway through that burning cycle. And that's when the sun has the lowest flux of dangerous radiation. But it's also a time when the sun becomes exceptionally stable in its luminosity. I mean, I have friends that are trying to measure the brightness variation of the sun. It's extremely subtle. We're talking parts per million in the variation of the sun's brightness. And so we are living indeed at a time when the luminosity brightness is the lowest. And yet what really sealed that was an experiment 10 years ago where they were looking at neutrino radiation coming out of the sun. And the interesting thing about neutrinos is that, they exit the sun very quickly. The photons do not. So the photons that are produced from nuclear burning take about 100,000 years to go from the nuclear furnace to the surface of the sun and then out to us. But the neutrinos we get right away. And so the neutrinos actually give an advanced look at what's going to be happening to the sun. And it was through that kind of research we're able to establish that the sun entered an exceptionally stable luminosity phase beginning a little less than 50,000 years ago, and it's going to exit from that phase in a less than 50,000 years in the future. So we humans are living in that narrow time window where the sun is especially beneficial for our existence. Now, I'm not saying you can't have human beings without that extreme luminosity stability, but if you want a large human population, it must have that extreme stability. And then I close the book off by saying we have an ice age cycle that has given us this incredibly stable climatic stability for the last 9,000 years. But it's something that can't be sustained for anything more than about 13 or 1400 years. So that's probably the narrowest time window of all, because in order to have billions of human beings, you do need extreme climate stability. And we're living at the only time in the history of the Earth where we've had that extreme climate stability coincided with extreme solar luminosity stability, coincided with the ideal temperature to be able to grow the food that billions of human beings need for their sustenance.
Mel, did you want to do a follow-up? Sorry, I finally got back to you here, Mel.
Sure.
It's an interesting topic. You know, we could just probably go for hours on this, obviously. Go ahead.
I have several questions. If we want to go back to the Drake equation, what I'm curious about is, since we have to have a certain amount of time in order for humans to develop, is it not possible, since we can't see all parts of the universe, for there to be some kind of simultaneous planet under certain conditions that kind of fall into that sweet spot that we have for life to begin and start, that perhaps we haven't just found yet? We don't have the Voyager data yet. We've already we've hit a wall when it comes to the observable universe. And I understand there are some planets that are probably too big to hold life because of the sheer gravity. But would it not be possible to, you know, I understand that this is just kind of playing around a bit because we don't have data for it, that there is some other point in the universe where we have life forms similar to our own that we just have not gotten to yet? I mean, in my thoughts, especially with the physics and the thermodynamics involved, and when we're looking at all of it, a living universe, to me, because things can fall into place in such a way, is the only possible universe in my particular thought of it, because we have carbon, because we have silicon, because things can interact and react and formulate into these compounds. It takes a long freaking time, but I feel, you know, in many ways, a living universe is really the only possible one, given how elements can interact in this particular way. So would it not be fair to think that maybe there's another spot in the universe that has simultaneous life similar to our own?
Yeah, that's certainly possible, because you know, what I was saying is we must be the first, but it's possible that God created something like us somewhere else in the universe and we haven't found it yet. But we astronomers have been looking. So for example, we've been searching for a spiral galaxy that's sufficiently like ours that it could be a candidate to have advanced life within it. And I cite some papers in the book of those kinds of searches. And so far, we've not found a single spiral galaxy sufficiently like our own that it could be a candidate. Kind of spoils my enjoyment for Star Wars, because it always begins with a galaxy far, far away. Well, we've looked at galaxies far, far away, and we haven't found any. Now you could say, well, we can't see these galaxies in sufficient detail at extreme distances. What if we were to look billions of light years away? Well, the problem there is we're looking earlier in the history of the universe. And so we're seeing the universe at a time when we know the conditions that wouldn't be right for that anyway. But another thing I talk about is how you need a special cluster of galaxies. And clusters of galaxies we can see at great distances. But we've yet to find a cluster of galaxies that's sufficiently like our local group of galaxies to be a candidate. And then we've been looking for stars. I mean, I have a lot of friends that are looking for planets that could be possible candidates for advanced life. And you know, they're using our powerful radio telescopes to try to hear or listen in to signals from these intelligent beings. But what I've been sharing with them is you shouldn't even be bothering to look if the star doesn't have the right conditions. And we've just been talking about how you need a perfectly middle-aged star. It's got to be exactly the mass of our sun. It has to have the same chemical composition of our sun. And my colleagues have spent almost 60 years trying to find a twin of the sun. We find lots of solar analogs. If you read the scientific literature, they do talk about solar twins, but they're not exact solar twins. They're not sufficiently like the sun to be a candidate for advanced life. And we've looked at literally millions of stars. Many stars are exact twins of one another, but the sun has no twin. So I've been telling my friends, don't even bother listening for intelligent signals if you know you got the wrong star. It doesn't matter what kind of planet you got orbiting that star. But if we extend it to planets, the list is now around 3,700 planets that we've discovered beyond our solar system. And the anticipation back in the 1990s, when we found these first planets, was it going to be just like the planets in our solar system? Well, after 20 years, we now recognize that none of them are like any of the planets in our solar system. Not only have we not found an Earth twin, we've not found a Saturn twin, or a Neptune twin, or a Venus twin, or a Jupiter twin. And that led us to the discovery. Every one of the 8 planets in our solar system plays a critical role in making advanced life possible here on Earth. We need every one of them. Matter of fact, we need 10, because our solar system today has 8 planets, but there was a time when it had 10. And each one of those 10 must be precisely the way they are in order to make advanced life possible on Earth. And the history of the dynamics of the solar system planets also must be very precisely fine-tuned to make advanced life possible here. And so it's not just you need a special planet like Earth, you need to have a particular planetary system. And you'll see a chapter in Improbable Planet where I make the point, you need asteroid and comet belts, exactly like we see in our solar system. And we've been finding asteroid and comet belts in other planetary systems. What we notice is none of them are like the asteroid and comet belts in our solar system. They're either thousands of times bigger or they don't exist at all. And what's necessary for advanced life is that you have 5 very small comet and asteroid belts so that we can exist here on planet Earth. And you will see NASA talking about how there's billions of habitable planets in our Milky Way galaxy alone, but all we're looking at is the liquid water habitable zone. And in the book, I talk about 8 different habitable zones and how these habitable zones don't overlap except here in our solar system. So for example, to have life, any kind of life, even bacterial life, you need the ultraviolet habitable zone to overlap the liquid water habitable zone. And for 97% of all stars, those 2 zones don't overlap. But really, to have life of any kind, you need all 8. And now we know of a 9th one. I wrote about this on our reasons.org website in one of my blogs. For life to be possible, a planet must simultaneously reside in all 9 known habitable zones, and Earth so far is the only one. So I'm not discounting the possibility of life elsewhere in the universe, but what I am saying, as astronomers, we've looked for that, and everywhere we look, we see hostility, except here on planet Earth. With one very important caveat. I've been on record since the 1980s. We will find the remains of life on every solar system body. That life must exist there. Those remains of life must exist there because of how prolific and long-lasting life has been here on Earth. Thanks to meteoritic bombardment, Earth has infected the entire solar system. So I'm convinced that NASA one day will find the remains of Earth life on the surface of Mars. But I actually got to speak at NASA Houston and at JPL saying a much better place to look is the moon. The moon has a huge treasure chest of Earth transported soil. And in that soil are quadrillions of the fossils of Earth's microbes. In fact, what's exciting to me, we'll never find the fossils of Earth's first life here on planet Earth, but we know they're there in pristine form in significant abundance on the moon. We can go to the moon and determine who got the origin of life model right, the theists or the non-theists. And as I told the NASA scientists, last time I checked, that was 100% of the US taxpayer base, so everybody should be excited about going back to the moon and solving one of the big creation evolution controversies.
Well, I know China's planning to go back there. I don't think I can quite agree that we would have to have all 9 or 10 planets. I don't think I can go that far. I do happen to agree, though, just by finding water, it doesn't necessarily mean that we can find life, obviously. And that right now what they do look for is obviously life. But you make in your book great points about other habitable zones, photosynthetic zones, ultraviolet habitable zones, ozone habitability zones. And I think those are fair things. I think people are dismissing them outright, without actually looking into them, which I think is kind of unfair. I'm reading the live chat, but I have read this book, so I think that to dismiss these other habitable zone conditions for life to exist outright is not being very fair. But I do agree with you that just finding water doesn't mean we're going to find life. And it is kind of odd that when we look into the universe and see all these different planets, we really don't find anything exactly like our own. I mean, even the most, what we think might be habitable, is still either too large, it might be a little bit too hot, but it's there, right? But we haven't really found anything exactly like ours. But that also could just mean that there's so much variety of different planets in the universe that, you know what, life might take hold in a different type of environmental conditions, would it not?
Well, I think what's unusual is we're looking at these extrasolar systems. They're so radically different from our own solar system that is driving the community of astronomers to the recognition that the planets in our solar system formed in a very different way, a largely unknown way compared to planets and other extrasolar planetary systems. In other words, the presumption was that our solar system would prove to be common. We're now discovering that it is indeed unique in its characteristics. Now, my peers are still trying to find analogs. And incidentally, they have found 2 planets that are very close to matching the characteristics of the Earth. But what shocked them is that those 2 planets came in super water rich, somewhere between 5 and 50% water content, which I would argue is to be expected. Water is the 3rd most abundant molecule in the universe, so I'm not at all surprised that they're finding these super water rich planets. But if you want advanced life, that's way too much water. In fact, I write in the book how planet Earth started off with that much water. So in that sense, our planet began as a typical Earth-like planet. It was a planet with oceans that were thousands of miles deep. But if that remained the condition of Earth, we would never get continents. And without continents above sea level, you can't recycle the nutrients, which means you might have bacteria existing for a few months, but not billions of years. You got to be able to recycle those nutrients. And surface continents coexisting with oceans are crucial for that. And that requires an Earth-like planet that's relatively water poor. I mean, to give you an idea, the water content of Earth is 0.03%. And everything we found outside the solar system is way above 5% and maybe as high as 50%.
Paul, did you had something to add? I know, unfortunately, we are in a time crunch. We only got Hugh for an hour today, but we're going to try to make the most of it. And I want to get also General in as well. But Paul, do you want to add something?
Well, yeah, I guess I mean, for me, obviously, highly improbable events can happen all the time. You know, the 7 of us being in the same conversation is massively improbable if you step back. So I guess my question is, if we were to find another planet that's relatively capable of sustaining human life, if we happen to find it, to a naturalist, that would make sense due to just the sheer number of planets out there and the basic math. And I'm guessing that a theist would attribute such a planet like as a gift from the creator or something. I guess, is that the correct way that would be interpreted, or would such a discovery falsify your improbable planet explanations?
Well, both myself and my colleague Jeff Zwirink here, is also an astronomer at Reasons to Believe, has made the point, from a Christian perspective, you've got lots of options. Because as we look at the Earth, it seems like the Creator really enjoys creating life with huge abundance and huge diversity. he goes to great effort to make millions of species on the face of the earth. And so you could argue from a Christian perspective that God is almost compulsively creative, in which case, why would he stop at one planet? And therefore, people coming from that perspective are saying, we're going to find life all kinds of places in the universe because God enjoys creating so much. But then there's another school of thought within the Christian community. It says when you read the New Testament, it seems like God doesn't waste miracles. Every miracle he performs is for a specific theological purpose. And what would be the purpose of creating life elsewhere in the universe? And, it looks like the purpose is to bring about the end of all evil and suffering. That's why God created the universe. That's why we have a universe with gravity and thermodynamics and electromagnetism, something I wrote about in a previous book, Why the Universe is the Way It Is. And therefore, from the perspective that God doesn't waste miracles, we would anticipate that this planet would be alone in possessing life. But both options are on the table for the Christian. It's basically more of a theological debate than a scientific debate, with one important caveat. There's a couple of chapters in the book of Hebrews that makes the point that the creator of the universe came to one place and sacrificed himself for one time to redeem human beings. One time, one place. So it would seem to eliminate the possibility that that creator created beings like us, physical, intelligent, spiritual beings that are in need of redemption from their sin and evil. But it leaves the door wide open for that same God creating a planet with dolphins, or creating a planet with grass and flowers, or creating a planet with lots of bacteria on it. And so this is an open debate, but as an astronomer, I can tell you everywhere we look, we see hostility for the existence of life, which seems to suggest that those theologians who take a conservative interpretation on God's miraculous interventions may indeed be correct. But hey, this is not settled yet.
But do you agree that in science we should take the position that the Bible doesn't give us the parameters for what we think may exist? If we find intelligent, sentient life out there that is very similar to humans, I mean, how would that change your model? Obviously, as people that love science, I don't preclude that possibility. I don't take the Bible to say, hey, because God needed this redemption plan, therefore it prevents humans or similar things being existing in other planets. Do you agree that there's a difference there from the perspective?
Well, yeah, most Christians would argue if we find life elsewhere, that in no way falsifies anything that the Bible teaches. The Bible simply doesn't address that subject of whether, our planet is alone in possessing the life that God created. I mean, I've got one colleague from MIT who says, I'd be really excited. In fact, I says, he believes that God must have created life elsewhere, because he says when we discover that, that will multiply the evidence for God's miraculous intervention, since we already know the origin of life is not naturalistic possible. So that's his prediction, that we're going to be finding life elsewhere, and that's going to strengthen the Christian worldview perspective. But again, you can take the theological perspective. God doesn't waste his miracles. And if he only needs one planet with intelligent physical beings on it like us, then why make more? But keep in mind that the Bible already has told us that God has made a different species of intelligent life. They're angels. And these are intelligent beings that are not subject to the laws of physics of our universe or its dimensionality. And, the Bible is silent on whether God has made other species of intelligent life. Who says that there's only angels and humans? Maybe.
But angels wouldn't be biological, though, right? They wouldn't be a biological species as what we would consider to be biological entities.
Well, it's difficult because the Bible says that these beings, though not subject to our physics, are able to enter into our physics and actually take forms of any physical nature they want. They could appear as a leprechaun. They could appear as a human being. They can appear as a flying saucer. They have those capabilities according to the Bible. And I've written another book, Lights in the Sky on Little Green Men, basically saying there is hard scientific evidence that we've experienced these kinds of interventions from these beings not subject to the laws of physics. So, I mean, that's a whole nother subject.
Oh, it is, and I think that's where I kind of diverge, because obviously I don't accept that we've ever been visited. I don't really believe angels, travel around and eat flying saucers. I mean, I've seen the arguments for against that, but I don't hold that particular position. But let me ask you, is your argument from Improbable Planet more from just a understanding of belief that these are probabilities that give someone a justification to hold the belief that God is responsible for all this, rather than the assertion that God did? So is it more just a possible warrant to hold that justification?
Yeah, it is a possible warrant to hold the justification that God indeed is responsible for creating the history of life that we see on the earth. But I try to take it a little farther than that and say it also reveals that there's a plan and a purpose and a destiny for God designing the earth the way that he did, for coming up with the explicit history of the planet that allows us human beings to exist, that allows billions of us to live here at one time, and develop the technology where we could actually discuss the theological significance of everything we see around us and draw the appropriate philosophical and theological conclusions. So I think there's a lot more going on in the fine-tuning than what people have been writing about in the last 10, 20, 30 years.
General, I know you've been trying to get in here. General, did you want to add something? Because again, I know we're kind of on a time crunch, but we could literally continue this for several hours, I'm sure.
Yeah, I can ask like maybe 2 or 3 questions.
Yes, right. Hugh has time.
Yeah, go ahead.
Nice to meet you again, Hugh. I've been missing you since your Perth arrival back in 2014. So you may have remembered me when I spoke to you with my partner. But, just quickly on this alien topic, are you aware of the early church discussion on passages like Colossians 1, Romans 8, and Ephesians 3 that mention that there's other things in the universe, so other life entities in the universe that Jesus creates, that he then redeems in the one act here on earth? And so they call it the principle of plenitude and the other worlds. Yeah.
Yeah, that's particularly popular in the Roman Catholic Church to cite those texts. I mean, having looked at those texts, I can see where you could possibly pull that interpretation out, but I could also see how you could read those texts that would eliminate that possibility. So that is a theological debate that's going on, just how to interpret those particular texts. And at least from my perspective, I think it's a bit of a stretch to claim that those texts are teaching that God has created life elsewhere. Again, I'm open to that possibility. I would argue that the Bible doesn't eliminate that possibility, but I don't see anything in the Bible that says that God must have created life elsewhere in the universe, physical life like us.
Okay, and just quickly on that, so if Earth is unique as far as the existence of life is concerned, so literally this is it, this is the only location where life exists, would that then obviously shock the non-theist into realizing, hang on a second, then that is interesting, right? Like that, the fact that we are alone would cause a anxiety, I guess. But would you say that that the same thought can happen if there's life? So a theist argument can work in both contexts?
Yeah, I mean,
or which would be more stronger, I guess?
That either way it goes, it has significant theological implications for people who are not Christians. I mean, if you've got a God creating life everywhere, that's impressive. And if we're alone, that has implications. And what I write about in the book is that, regardless of whether it's here or elsewhere, the time window for advanced life is rapidly coming to a close. I mean, for example, you've got Stephen Hawking making the point, we got to find another planet because our planet isn't going to sustain us for much longer. He's correct that our planet can't sustain us for much longer. However, I think he's barking up the wrong tree and thinking it's going to be easy to find another planet that we can go to. I mean, we've been looking. Everywhere we look, we see hostility. And given how quickly our planet is going to become unsustainable for human civilization, it's clear we don't have enough time to find another planet, which means we need to think through the theological implications of the fact that we can't live here for a whole lot longer period of time.
Yeah, I definitely
heard
think there's
you.
oh, go ahead, General.
I've heard you give the ballpark of between 500 and 1,000 years from now, we'll be in serious danger as far as, like, in this case, human extinction.
Well, it won't be human extinction,
Yeah.
but it will be the extinction of billions of us living with reasonably high technology and standard of living. I mean, I think we could keep on persisting on this planet for another million years if we're willing to exist on this planet at a population level below 1 million, where we're basically going back to a Stone Age technology. However, I've talked to my sons and said, what do you think of that future? And they said, we prefer to go extinct.
Yeah, I don't think you need too much theology just to go into the fact that we will one day face another extinction level event. I think that's kind of goes without saying. I mean, you point out in the book how many extinction level events we've already been through. I mean, I think there was like 5 major ones, and of course, we know that there's bound to be another one: comet hitting, asteroid hitting, gamma ray burst, flare, whatever. There's something that's going to affect us that will diminish our overall population. I think that goes without saying. Now, but your argument is basically that you think that there's been divine intervention to prevent this from completely wiping out humanity, correct?
Yeah, that's right. And I'm also making the point that it's going to happen a lot sooner than we think. I mean, yeah, about every 30 million years, we go through the plane of our galaxy, which disturbs our asteroid and comet belts, and that's when you get these mass extinction events. But if we're talking human civilization, at a high population, high technology level, that demands extreme climate stability where you're living in an ice age cycle, where you go between cycles of 23% ice coverage and 10% ice coverage. And so that alone gives you an extremely narrow time window in which you can sustain a large human population. You know, and that window is going to close in something between 100 and 1,400 years. That's not a lot of time. So what I basically close the book off with, that has very profound philosophical and theological implications that every human being needs to consider.
General, you want one last question, then we're going to have to wrap it up here.
Yeah, one more question. The mention of extremophiles is in Hugh's book in chapter 8. And in that chapter, so this is on the footnote 48, because I have the book open. And just early in the chapter, you mentioned about the 1 kilometer deep ocean during the late heavy bombardment, like when water accumulates. And all I could think about in this chapter as a Christian, all I could think about is basically Genesis 1 verse 2. And therefore, just in the prior discussion in regards to the origin of life, has life been, can it be viewed naturalistically, or will you always emphasize, based on that particular verse about the spirit hovering, would you always emphasize that it's definitely a divine fiat, that God, it has to be God bringing about life within the oceans?
Yeah, I mean, throughout the biblical creation text, God takes the credit for life existing here on earth. And so that would imply that his intervention is necessary to get life here. And Fazal Rana and I have been attending these Origin of Life research conferences. We read the research literature on this, and there's actually a site on our website where we list these research papers and give you links. And, there's a consensus within the Origin of Life research community is that there is no naturalistic resolution to the origin of life. Now, it doesn't mean they're not looking, but the very fact that they acknowledge that it's impossible to solve the homochirality problem, and there's no way that we can get the building blocks in sufficient abundance levels where we can get things like bacteria showing up. And I think what's particularly disturbing to the Origin of Life research community, the first life on planet Earth isn't just one simple bacteria. It's an entire ecology of microbes with different metabolic pathways, including photosynthetic life. And I think what really surprised me in going through the scientific literature is how you need photosynthetic life to ignite and sustain the plate tectonics. It's the photosynthetic life that brings uranium precipitates in its subduction zones, and how that heat is crucial to launching and sustaining the plate tectonics. So there's this incredible synergy throughout the past 3.8 billion years. You need life of a particular type at a particular abundance level to keep the plate tectonics going, but you also need the plate tectonics to sustain life here on planet Earth. There's this incredible synergistic relationship between life and the plate tectonics, and both of those are in a synergy with what I call the faint sun paradox, how you got the sun getting brighter and brighter as it gets older and older, which challenges how do you sustain life on the surface of the Earth? Because as the sun gets brighter and brighter, that would raise the temperature at the surface of the Earth. But what I document in the book is that by God creating just the right life at just the right time and periodically removing life that's no longer suitable, he's able to use that life to draw down greenhouse gases in the Earth's atmosphere. So as the sun gets progressively brighter and brighter, our atmosphere becomes less and less efficient to trap the heat of the sun, maintaining a surface temperature for 3.8 billion years that's optimal for life. And my whole point is only a being that knows the future physics of the sun, of the Earth, is going to know which life to have on the planet at which time, in which abundance. And from a naturalistic perspective, you would anticipate that very quickly the life on planet Earth would get out of sync with the physics of the sun, and our planet would become permanently sterile. But that's not what we see.
I definitely have to, though, disagree on what you said earlier, though. I don't think there's many scientists, if any, that actually say that life couldn't have began naturalistically, or there's such a problem with homochrality that we cannot ever have said that life could begin purely by naturalistic or teleonomic means. I don't know what citations you would have to actually support that.
Okay, yeah, and again, I think you're misinterpreting me. What I'm saying is they have no naturalistic scenario to offer. It's not that they don't even have an interpretation. They don't even have a scenario. And that's kind of a standard in science. If you don't even have a possible scenario to explain your particular model, your model is considered to be a failed model. Now, I will agree with you that when we attend these origin of life research conferences, they say, well, we recognize that everywhere we've looked, we've failed, but we're still looking. But what's interesting is their search is now focused on trying to make it in the lab. But as we've been engaging these scientists, we've been making the point that's not relevant to what happened on the Earth. The fact that you can do it in the lab is simply testifying you need a lot of intellectual input in education and technology to make it happen. So we're using an analogy argument. But we would anticipate that there will always be scientists who say, we don't think that there's a God out there that made it happen, in spite of the fact everywhere we look, we see intransigent problems. But again, I would argue, if everywhere you look, you see intractable scientific problems, that should be good evidence that you've got a failed model.
Well, just because we don't know something, I don't know how that differs from a typical God of the gaps argument. And there have been many papers out there. I mean, in fact, just in our community, somebody did a whole thing on one of the papers having to solve, or at least give an explanation, not solve, because the homochrality problem clearly isn't solved, but possible explanations. And isn't that kind of what science does? It provides possible explanations and then kind of test it.
Well, that's what I've been looking for, Steve. I've been looking in the scientific literature for a possible scenario on how to solve the homochrality problem, or a possible scenario on how you can get the building blocks at the necessary abundance levels. That's what's missing from the scientific literature. In fact, you see papers published basically saying the opposite, is that we're not going to find these kinds of possibilities. That to me is a symptom of a failed model, when you can't even suggest a possible pathway.
Well, let me find that particular thing, and I'll definitely get it to you. I don't know if I can go so far to say, because we don't know something, a scientist would ever say we can't ever explain it. I just don't see that in the scientific community.
Yeah, and that's where I close, saying, we never as human beings can close the door on possibilities because our knowledge is limited. We don't know everything. However, what we do in science is take competing models and say which one has the best success on the gaps of knowledge. In other words, are we seeing as we learn more and more that the explanatory gaps are getting smaller and smaller and less problematic? Or as we learn more and more, do the explanatory gaps get bigger and bigger and more problematic? And you can get or document that we're seeing the latter from a naturalistic perspective. The explanatory gaps are getting bigger and bigger and dramatically bigger and bigger problematic as we learn more and more. And interestingly, our book Origins of Life got reviewed by David Deamer. He's one of the top Origin of Life researchers, a lifelong atheist, and he contacted us after we brought the book out and said, do you mind if I give it a critical review? And we said, yes, you can give it a critical review. He said, well, I'm going to be very critical. And I says, the more critical you can be, the better it's going to help us because we want to improve our model. And so he wound up publishing a review in Origins of Life and Evolution, a peer-reviewed journal. And basically what he says in that review, and you can check it out, he says the book by Ross and Rana was the most scientifically interdisciplinary treatment of the origin of life that exists in the published form. He says, I like everything about the book except the Jesus Christ part. And so the very fact that he endorsed our book in the sense that, we were accurately describing the history of origin of life research. And, they're the only meetings that I've personally attended where the meetings get more depressing and despairing every time they meet because of the fact that the problems are becoming even more intractable than they were before. And I think this is something the public's not aware of just the situation. Because when I go to other scientific meetings, you walk into the auditorium, it's crackling with excitement, enthusiasm. People are in a state of joy over what they're learning, the problems they're solving. We see the exact opposite when we go to an Origin of Life research conference.
Well, I would have to ask the people that go to those conferences, but I know we have to definitely start wrapping this up soon. I will add this before I give you the final word. Again, in this book, Improbable Planet, I think a lot of people would be surprised by its content. I was pleasantly surprised. It is quite annotated. It is quite involving science. I'm not a scientist of any measure, so I cannot really put my 2 cents as far as the scientific content in here. I don't see anything that stands out as being like completely wrong scientifically. And if anybody wants to read it and if they find anything, please let me know. I'm sure Dr. Ross would be happy to address those things. But I don't see anything in this book that I just think outright is non-scientific or not right. You just put a lot of facts in here, a lot of annotations, and then not to the end you actually make the conclusion. Or at least make the argument that there's something more involved as far as the theological approach, which I think is fair. I mean, it is an apologetic overall tone, but the actual book itself isn't very tailored for apologetics. This is the facts, this is the science, and then you draw a conclusion. Would you say that's kind of a brief synopsis of the entire thing?
Yeah, I think you've read it correctly, and I'm basically trying to communicate, look what's been discovered in these disciplines of science in the past 3 years. I mean, I've been astounded by the advances that have been made. And I just want people to know what's been happening here. And I'm kind of using the approach, hey, these are the facts. If you want to check it out, here are the research papers. Here are the links to the papers. You can see for yourself. And when I tell lay people, you can always read the abstract of any science research paper for free. Go in and look at the scientific details, and you'd be amazed how much of it is lay accessible. So I'm hoping people will dig into it and just be amazed at what's been discovered in the past 3 years, but also to be able to think about, what does this mean for me? What does this mean for the human species?
Wayne and Hunter, I know you guys, I know we don't have time for probably any other questions, but you just want to say something real quick to say hi to Hugh? Hunter? Hunter, are you there?
Yeah, sure. Dr. Hugh, actually, this is Hunter Bailey. I'm a friend of General's and Steve's, and Wayne, actually. I'm not familiar with the other two that much, but huge fan of your work. I've actually looked into your undergraduate programs on your online website, and I'm actually looking into like doing some courses on there. So just really appreciate all your work, and really appreciate everything you do, and just God bless you. Thank you a lot for everything that you do.
Oh, you're welcome. Thank you for sharing.
And let's get Hugh in. Let's get Wayne in real quick. Hey, Wayne.
Hey, hey, Dr. Ross. Nice to see you again.
How
It's
are
been
you?
a long time. I've been good. I've been good. I've been reading more of your work. I definitely use a lot of your material, so I can try and convince some of my non-believer friends. And just keep up the good work, Dr. Ross.
Well, thank you.
Well, let me just add one quick thing that we engage with a lot of theists and a lot of atheists, and there's a lot of people in general. And obviously, Hugh and Fuzz have been so generous to us, and literally my favorite guest to have on, because we can have these types of discussions. They're not confrontational, they're non-adversarial. They're just, hey, let's talk about this stuff. And I'm thrilled to death that we can have these types of discussions. I know people love these types of things. They want more of it. And I know that, obviously, Hugh's time is very, very limited, but obviously we have a direct connect to him. People want to ask questions. I recommend they read this book. I'm objective, and I don't throw this out there as a menial caveat. It is worth reading. I would tell you if it wasn't. I have no loyalty to just to throw something out as saying that, oh, well, I have a guest on, it's a great book. No, this is a very interesting thing that he put forward. If you literally just took out any kind of thing for theology, this would make a great just scientific textbook for just for generalities of astronomy. I mean, and things of that nature. It's quite interesting. So I do recommend it that way. And if people want to give me their feedback on it, I'm sure Dr. Ross, you'd be interested in what they have to say about it as well.
They would, because we're thinking of putting out a new edition, and there are typos in the book, so if you find anything like that, please let us know. And yeah, I'd be happy to come back and dialogue with people after they had a chance to look at the book.
Absolutely. Awesome. All right, so let's kind of wrap this up.
Can I just quickly say one more thing?
Yes, yeah, of course.
Hugh, I'm looking forward with your interaction with Ken Ham in the Counterpoints book that's coming out in November. I saw the coming soon. I think Zondervan put up an ad.
Yeah, they just put up an ad for the 4 Views book. And yeah, it's a remarkable book that involves the presidents of the 4 largest creation science organizations: Ken Ham, myself, Steve Meyer with the Discovery Institute, and Deborah Harzma with BioLogos. And
can't wait for that.
The book is done, and I can tell you that for the first time, these 4 organizations actually had to lay out what they believe and why they believe it.
Can I predict that Ken Ham is the usual Ken Ham, like he's been in all the discussion?
Well, he's much more civil than he usually is in public debates, mainly because the editor made certain that would be the case.
Right. Any new novel ideas or any new stuff that you've introduced in that book in your responses, or?
Well, what's interesting
drawing from prior work
is that all 4 presidents said they believe in the inspiration and inerrancy of the Bible, but they all had very different definitions. And you can actually pick up another book called Controversy of the Ages by Ted Cable, where he observes the same thing. They all use these terms, but he says there's only one organization that really holds to biblical inerrancy, and that's Reasons to Believe.
I was going to ask, when is the date for that? You said it's in November?
Coming out in November. Yeah, it's already up on Amazon.
Oh, okay. I got you. Because my birthday's in November, so I didn't know.
And we'll be making it available here at Reasons to Believe.
Oh,
and
sweet.
Already a 2 Views book out that you can get that features us and the evolutionary creationists of BioLogos. That's already out.
A couple people have been asking if they're going to have an after show about this. We might to talk about this. We usually kind of do, but it probably won't be for I don't know, maybe right away. We'll see. We'll discuss it afterwards. But Hugh, once again, I want to thank you very much for coming in and joining us. The Great Debate community, loves talking about this stuff, and I think overwhelmingly, whether they agree or disagree with the theology, the overwhelming thing that I've gotten for feedback has been that Reasons to Believe has been great to interact with. They are the type of theist that we like to have conversations with. They've been more than generous to us, and I mean, this just raised the bar for these kind of conversations. So I couldn't recommend them enough. If you want to learn about the reasons to believe and their mission statements and things like that, go over and check them out. The link is in the video description. And again, read Improbable Planet, and let's talk about it, because I think it's worthy to have a conversation with. But Hugh, do I give us the last word on that, and then we'll take us out?
Well, Steve, it goes both ways. You've been very gracious towards us, and these are the kinds of dialogues that we really enjoy and look forward to, because we've been on other shows like this where we don't see that same demeanor. So we appreciate you being so generous towards us, and actually having a dialogue where we can learn from one another in a civil way. So thank you for making that happen.
And thank you. That means a lot to me, and it means a lot to the Great Debate community, and we will continue along those lines. With that, thank you everybody for watching. Had a huge audience this particular hangout. If we do have an after show, it probably will be within a half hour or so. But anyways, thank you, Dr. Ross. Thanks, Fuzz, for when he comes on. Please give him my regard, and of course, Anastasia, who was just absolutely magnificent in how she handles these types of setups to get these things going. So please give her my best. And anyways, guys, thank you very much for watching. And that's going to do it for us today. Thanks, guys.